Okay, so here we are in lesson 9. This is our last lesson in the unit. You have made it all the way through your first unit in 7th grade math. So, lesson 9A, students will be able to find the sample space when dealing with compound events. Students will be able to use correct vocabulary when discussing probability, and this is important for real-world problems, like choosing dinner and dessert from a menu. That says menu. So what the probability would be of choosing a specific dinner and a specific dessert. So these are called compound events. So a compound event, to find the sample space, we can use tables, lists, or tree diagrams to help us. All right, so here's what that looks like. Let's look at number 1. An experiment consists of flipping 2 coins. So we're going to be flipping 2 coins and looking at the total number of outcomes that we could possibly get. So we could put that in a table. So here's one way. So I'm going to abbreviate head as H and tail as T. So one combination we could get is heads and then heads. Another combination is heads and then tails. Or tails and then heads, and then the other possible outcome is tails and then tails. So we could sit there and make a table of all the different outcomes on each coin. Or we can make a list, heads then heads, heads then tails, tails then heads, tails then tails. That's what the list would look like. Or a tree diagram means you list the first coin in the first row and then the second coin in the second row. So if I go from heads in the first coin, then the second coin could either be heads or tails from there. Or if I start with tails in the first coin, then the second coin could either be heads or tails from there. So what would the probability of having one head and one tail be? Well, we look at our total outcomes. So we have 1, 2, 3, 4 total outcomes, and we see just having a head and a tail. So it doesn't matter what order. That's why I wrote it over here, not in order. So having one head and one tail, that could be one option, or this could be the other option, right? So we have 2 different choices there, this one or this one, and then head and tail, so these, or head and a tail, so those. But either way, no matter what way you show the whole sample space, we see there's 2 out of 4 outcomes of getting a head and a tail, and if we reduce that, that is 1 out of 2. All right, so the fundamental counting principle. When there are m ways to do one thing and n ways to do another, then there are m times n ways of doing both. So and means multiply. I want you to see that. And means multiply. So remember, if we have to get both at the same time, then the chances are less likely. We need to multiply those outcomes because it's harder to get both things at the same time. For example, what about having 2 coins and having both of them be tails? So again, we can sit here and list out all this. Don't worry, I'm going to show you an easier way though. But we can sit and list it out at a table. Heads and heads, heads and tails, tails then heads, tails then tails. There's our list. There's our tree diagram. Remember, you can always pause this video if you need to copy all that down. But out of all of these, how many chances are there of getting both tails? Well, in this list, I see I get tails and tails just 1 time out of 4 total outcomes. So 1 out of 4 would be the probability there. And number 3, still dealing with 2 different things, but this time we're looking at 2 fair number cubes. And so the first thing I want to think of is the total number of outcomes, so that I know if it's something worth making a list for or not. So we'll see in this case. But 2 fair number cubes. We know the first number cube has 6. Different outcomes, 1, 2, 3, 4, 5, 6. The second number cube also has 6, but rolling both of them at the same time and means multiply. So we're going to have 36 total outcomes here that are possible. So whatever we look at, it's going to be out of 36. Now we look at what we're looking at. So it says a sum of 7. So that's something we actually should list out. So let's think of a sum of 7. So if the first cube is a 1, the second cube would have to be a 6 to have a sum of 7. If the first one were a 2, the second one would have to be a 5, right, to have a sum of 7, to add them up to 7. If the first one's 3, the second one would have to be 4. If the first one's 4, the second one would have to be 3. If the first one's 5, the second one would have to be 2. If the first one's 6, the second one would have to be 1. Again, I'm looking for all the totals of 7, and there's no other possibilities there. And so out of all the 36 possibilities of rolling 2 number cubes, we would have 1, 2, 3, 4, 5, 6 different outcomes that would result in a sum of 7. So that would be 6 out of 36 total possible outcomes, and we reduce that for a 1 in 6 chance. All right, turn to the back. Same thing, looks like we're still looking at 2 fair number cubes, so the total number of outcomes is still going to be 36. Remember, 6 on one, 6 on the other, 6 times 6 is 36, but this time they're looking for at least one 5 being shown. So if you think about that, what if the second cube were 5? Then the first one could be 1, could be 2, could be 3, could be 4, could also be 5, could be 6, right? So it could be any of them on the first cube as long as the second one is all 5. So at least one 5 being shown. We could have 2 5s, but at least one. And then let's now keep this first cube all 5s, right? So first cube could be 5, second cube 1, 2, 3, 4. I skipped 5 and 5 because we already had that one listed here, and then the first one could be 5, the second one could be 6. So we're just listing all the different ways we could get this outcome, the outcome we want. And now we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different ways to get this outcome out of 36 total outcomes possible on 2 cubes. All right, number 5, an experiment consists of rolling 2 fair number cubes again. All right, so 2 fair number cubes, the total outcome, so I'm thinking of the totals at the bottom. So total outcomes, one number cube has 6, the other number cube has 6, so if I roll both of them, there's 36 different outcomes possible. And out of all those outcomes, if I were to make a list, if I want double 6s, how many ways can I get 6 and 6? Well, that's 1 out of 6 for the first cube, 1 out of 6 for the second cube. So if I multiply those together, it's just a 1 in 36 chance. That's a 1 in 36 chance of getting both 6s. 6 and then another 6. That's a 1 in 36 chance. All right, so let's look at some other situations that aren't number cubes or coins. Let's look at Garcia. So Garcia here has a quarter, a dime, and a nickel in his left pocket. So let's write out, okay, so he's got some coins. Okay, he's got a quarter, a dime, and a nickel. In his right pocket, he has a blue marble and a red marble. So marbles, he's got a blue, he's got a red. Blue or red. If he selects a coin from his left pocket and a marble from his right, what is the probability of holding a dime and a blue marble? So what they're looking for here is the probability of getting a dime and a blue at the same time. All right, so dime. How many of his coins are dimes? Well, it's just one. One of them are dimes. One dime out of how many coins? Well, 3 total coins, right? All right, how about the marbles? So how many of his marbles are blue? Just 1. Out of how many total marbles? Just 2. And so the probability of those happening at the same time, we would multiply those together, and we would get a 1 out of 6 chance. So there's our probability for picking out a dime and a blue. It's a 1 in 6 chance. What about Liza down here? On Liza's bookshelf, she has 4 math books, numbered 1 to 4. All right, so let's write out her math books. She's got math books 1, 2, 3, and 4 on her first shelf, and 3 puzzles labeled A to C on the second shelf. So second shelf has puzzles A, B, and C. If she chooses a book and a puzzle at random, what is the probability of getting a book with an odd number and a puzzle labeled C? So we're looking this time for an odd numbered book and a puzzle that is a C. Okay, so let's look at this. Odd numbers. Out of the math book, I've got a 1, I've got a 3. Those are my only odd numbers. So I've got 2 out of 4 of the math books have odd numbers. And out of all the puzzles, only one of them has a C. So 1 out of 1, 2, 3, 1 out of 3 would be from the C's, right? Would have a C on it. So the probability of getting both of those at the same time, an odd and a C, means we're going to multiply those numbers together, and I get 2 out of 12, which we can reduce by 2s and get 1 out of 6. I promise not all these answers are going to be 1 out of 6. That's a coincidence. Okay, hopefully you see where I got this. I want you to actually try number 8 on your own. Number 8, what is the probability of rolling an even number on a number cube and tossing a tail on a coin? So go ahead, write out the sample space. It really does help to write each one's sample space first, like I was doing up here. Write out the sample space. What are all the possibilities on the number cube? What are all the possibilities on the coin? And then go ahead and figure out what would be the probability of rolling an even number, and tossing a tail on the coin. So what would be your probability of an even number and tossing the coin and landing on tails? All right, so go ahead and figure that out. I know this one's a little bit tricky. Take your time on it. Raise your hand when you're done. This is our very last lesson. Woohoo! We made it through the end of Unit 1. What? Now it's time to review. Yay, Test Friday. All right, raise your hand. Show me number 8 when you're done. And make sure to ask me if you have any questions about how I got these numbers. Talk to you soon. Bye-bye.